In this illustration, we'll analyze the changing direction of motion of a spaceship. Here we are given that a spaceship of mass m0 moves in the absence of external forces with a constant speed v0. And to change the direction of motion, gases are ejected from rocket in a direction normal to its motion at velocity u relative to this rocket or a spaceship. And we are going to find the angle by which the direction of motion of spaceship changes when its mass decreases to m. Here in this situation we can see, if we draw the situation, this is the rocket which is of mass m at any time moving at a velocity v0. Now to change the direction of motion, if a rocket is fired in the direction from the rocket, gases are ejected in the direction perpendicular to its motion, and these are given to be ejected at a speed u relative to rocket. Then we can see in a time dt a mass dm of gases are ejected out, due to which it experiences an impulse in opposite direction, and say the velocity direction changes by an angle d theta. But as it is acting in the direction perpendicular, we can assume the speed remains constant. So we can write, if in time dt, dm mass of gases are ejected, this implies by conservation of momentum in direction perpendicular to motion, we can write in direction perpendicular to motion, the momentum attained by gases will be dmu, and on the other side it will be the momentum gained by the spaceship, which is mv0 sine of d theta. Here we can also write m minus dm instead of m, but the product of dm with the sine d theta would be negligible. So here we can see this dmu is equals to mv0 d theta. As for a small angle sine d theta, we can write as d theta. And here further we can write it as dm by m is equals to v0 by u multiplied by d theta. And if we integrate this expression, initially the value of theta was 0 when the mass of spaceship was m0, and say if it changes to an angle alpha when the mass reduces to m. Here we can substitute a negative sign because theta is increasing and mass is decreasing. So in this situation we can write it as ln of m0 by m is equals to v0 by u multiplied by alpha. Here you can also write negative sign is introduced as dm is negative, because in this situation the mass of a spaceship is decreasing, so dm is negative, that's why we are taking it. And on further simplifying, this gives us the value of alpha, which is u by v0 ln of m0 by m. That will be the result of the problem, the angle by which the direction of a spaceship changes when its mass decreases from m0 to m.